fellow viewers, this is Brian here at Applifast. Today we're presenting you with advanced fastening systems with process control. The system that we're going to be demonstrating is from Desoutter Industrial Tools. This is a wheels-on demonstration that will resonate well with those of you in the bus manufacturing industry, or the truck industry, or the trailer manufacturing and agriculture industry, such as this wheel we have here today. I'm going to go over all the components of this advanced fastening system so you can understand how they work together to provide process control in your manufacturing environment. So let's start off with this tool here. This tool is a transducerized DC electric pistol grip swing bar nut runner, and we have a powered socket and we have a reactionary socket on a sliding reaction bar that allows us to position it on the adjacent nut to absorb the reaction force when we're fastening. The tool is suspended by a tool balancer. We also have torque tubes that can be used in your production environment depending on how the system is set up. The tool is powered by a cable that is going back to our DC electric tool controller. This is our CVI3 Vision controller with a touchscreen operator interface. There is torque and angle results being presented here to the operator, but this is also synchronized with the operator guidance software that's seen on the touchscreen monitor there for the operator to follow through the assembly process. So what is an assembly process? An assembly process is written through software to the controller. That assembly process is started with unique identifiers, such as the VIN of the product that you're manufacturing, the application, and perhaps an operator's badge, as I've got with me here today. But then we enter into the fastening assembly actions, which are parameter sets that are done in specific sequences according to a batch quantity of your product. So if you're fastening 6 fasteners, we'll go through a sequence of 6 fastenings, and then the assembly process will be complete. But you can also add other parameter sets with different batch quantities. In the assembly process, they can be very simple to very complex, and the controller can handle it all. So, in order to initiate an assembly process, to prevent input errors by the operator, we will use a barcode scanner. So in the workstation, we will provide them with scan sheets. So when the vehicle enters into the work center, the operator will scan the vehicle identification number, whether it's on a sheet that you attach in the window, or it could be on the actual VIN on the vehicle itself if it's on at this stage. The operator scans that barcode, and the controller will either accept or reject it according to the data that it's received. And then we scan the application barcode. Well, this wheel looks a lot like this wheel here today, so that's the correct application. We're going to scan the wheel. Again, the controller recognizes, is that a good or bad barcode scan? And then the third component that's commonly acquired is the employee badge. And again, this can be a 1D or a 2D barcode. What that did, now that I've scanned all 3 of those scans in a sequential order, it has changed the display on the controller. But wait, there is still a stop sign on the screen and the tool is still disabled. We have put an extra error proofing level on this system so that you know your operators will always be fastening the correct torque value on the fastener that the tool is fastening. How do we do that? We do that with a socket tray. So when the operator comes to the smart socket tray, each socket position has 2 lights above it. They're off right now, except for one, which is illuminated with the flashing green. That is the socket that the operator needs to lift to enable the tool. When he lifts the socket, the green light goes steady and the red light goes steady as well. If an operator is to lift more than one socket, the tool will not run. Only one socket can be removed from the tray in order for the tool to fasten. So you would mount this socket onto your tool, and then the operator would look up at his operator guidance screen saying, Which fastener do I do first? Well, it's evident that the top left corner is where I need to put my active socket, and my reactionary socket goes on the fastener adjacent to it. So I place the tool on the fastener, and I've achieved, my target torque is 80 foot-pounds. I've achieved 81.18 foot-pounds and 17.3 degrees of angle. So it's important to understand we have a target, and the target can be any number within the tool's torque range. And we can control the torque and monitor the angle. We can in fact do angle control and torque monitor, but most commonly it's a torque control, angle monitor, or torque and angle control. So any specific requirements you have, we can program the controller accordingly. So we've got a good fastening there. The socket has relaxed in order to get the tool off onto the next fastener. The operator would wonder, what fastener do I do next? Well, he looks at the operator guidance monitor. There it is. It's the bottom right fastener. So he puts his active socket on the bottom right, reactionary socket on the adjacent fastener, and he achieves torque. The lights are green on the tool, so there's some feedback there. And we go to the next fastener. Well, the next fastener happens to be number 3, bottom left. So I put my powered socket there, my reactionary socket, and he fastens. We've got another good fastening. All these good fastenings are illuminated with green. We can see on this last fastener I achieved 80.82 foot-pounds, 19 degrees of angle, and my tool is still ready. So I'm going to move on. And in this case here, I'm going to show you what would happen if an operator would release the trigger before we achieve target torque. So I'm placing my active socket on the 5th fastener here, as illuminated on the screen, and I'm going to try and release the trigger early. So I have received a red. You'll see the monitor changes, the controller changes. This fastener is illuminated in red. There are several ways to release this tool from this reject interlock. And one of the ways is to set the tool up with, put the tool in reverse to remove the fastener and give the operator one retry. You can give them more than one retry, but typically we give them one. And if there's a continued issue on this fastener, the operator needs to phone their supervisor or call them and get them to come to the station, understand what's happening in the joint, and then adjust the tool accordingly, or rerun the fastener, or reject the complete wheel set. There may be an issue with the stud, there could be an issue with a nut going on the stud, or it could be an issue with the rim. Many different variables, and the tool in that scenario is doing its job for you. That is what you're using DC electric tools for, is to catch these anomalies, these things that you wouldn't catch with tools that weren't intelligent. And that's why we call this an advanced fastening system. So I'll show you. If I put the tool in reverse, I can back this fastener off, and then I'm going to take my first retry to achieve a good torque. And when I do that, the light turns to green and we move to the 6th and last fastener in the batch. So I slide my tool off and I move to the last fastener, and I've achieved 6 good fastenings, and my assembly process is complete. The stop sign has reappeared on the controller screen, and I can see that there's a duplicate of the controller screen right here on the operator guidance panel. And I also can show you now that I've completed the first batch. You'll also recognize how quiet this tool is. These tools have no impact mechanisms inside them. They're strictly gears and electric motor components that work harmoniously to fasten with almost no noise output. You can only hear the electric motor, and that's a wonderful advantage for your manufacturing environment. The operators will love the improved working environment, and the morale will increase with those good ergonomics. So you'll also notice there was no reaction force, and we mentioned earlier the tool's suspended, so it's weightless. You can move it with a few fingers, and position it with 2 hands is easier. It's safe to use. The operator's hands are both on something while he's fastening. We do have different reaction devices if you need them. There's light on the tool that shines on your parts if you're working in dimly lit areas. This cable can come out the top of the tool, can come out the back of the tool. There's many options to meet the needs of every workstation. Experience Applifast for yourself by calling us or contacting us on our website at applifast.com.